numerical solution of equations. Diagram shows a trapezium ABCD, AD equals BC equals R, AD equals BC equals R, and AB is 2R. Acute angles BAD, ABC, X radians, circular meet at M. Okay, so we need to show this. Given that the sum of the areas of the shaded sectors is 90%, so the shaded area 90% of the trapezium. So this means 2 times the area of the sector. Sector means the pizza slice here, equals 0.9, 90% of the trapezium area. Now for the trapezium area, we know that for the parallel sides, we know that this is 2r, so r plus r, that's going to be 2r. We know that for sure. And we know that the radius of the sector, the pizza slice, is r and the angle is x. So we can find this area, no problem here. Problem is when we want to find this trapezium area, we don't know the length of the other parallel side and the height of the trapezium. So let's just focus on this triangle here. I'm calling this point P, the foot of the perpendicular from D. So this is R, this is the angle X radians, and it is X radians. So we have a right angle triangle using sine and cos. So if we use sine is opposite over hypotenuse, which means we can find the height of the trapezium, the dp, which is r sine x. And using cos, we can find the ap. Cos is adjacent over hypotenuse, ap over r. Multiply both sides by r, we get ap equals r cos. So that's ap. So this is r cos. And now if we look at this r cos again here, so the PM is AM minus AP. We know that the AM is R, we know that the AP is R cos, which means the PM is R minus R cos. So if you want to find DC, that's just twice of PM. So that's 2 times R minus R cos. So now we have everything we need. So for the area of the sector, we use this formula in the MF19. So the area of the sector is 1/2 times the theta and r squared. And for the trapezium, sum of parallel sides, we know this is 2r, and we know that this is 2 times r minus r cos previously, and the height of the trapezium is r sine. So 2 times 1/2, that's just 1. And if we divide by 2 here, we have only r plus r minus r cos. R plus r is 2r. And we can divide both sides by r squared here. So r squared cancel out. And this is r times r, so also r squared, they all cancel out. We have only 2 minus cos x in the brackets times sine, which is what we need to prove. Alright, wait, part B is here. Verify the x lies between. So this is the equation we need to prove before. So to verify, we move everything to the left or to the right. So here we move everything to the right. We have 0 equals something, and we use the right hand side here. Plug in 0.5, plug in 0.7. You should get something negative, something positive, and draw a conclusion. Therefore x lies between. So that's how we verify. And for the next part, show it will converge to the equation in part A. So this is the equation in part A. So basically we have to rearrange this equation into this. So we can start by ignoring all the subscripts, the n plus 1 and the n here. So it's just x equals inverse cos 2 minus x over 0.9 sine x, and then we can use cos both sides. We have cos x equals this guy here, and then we can move this term to the left, so we add both sides by this term, and we can move this term to the right, so we subtract cos x from both sides, and then we can multiply both sides by 0.9 sine x, so we get 0.9 times this guy times sine x, which is what we need to prove. Alright, last part is to use that iterative formula before to find the x. So previously we have verified that the x is between 0.5 and 0.7, so just use the number exactly in between, so that's the average. We add, divide by 2, we get 0.6. So this is our initial value. We replace the x with 0.6, and we use radians, of course. So just the right hand side here, we don't use we don't move this x to the right or something, so just this part only, we replace the x with initial value 0.6, use a calculator in radians, we get this, and we go back. So don't clear everything, just press the left button, go back, replace the 0.6 with the answer button, and hit the equal sign, equal symbol again. We have this number now, and then from there on just press the equal again, and so on. And if you want to check, if you want to make sure you're doing it right, keep pressing the equal sign many times until the displayed number doesn't change anymore, because that means you're doing it right. If the number keeps changing, and if it's not converging, so it keeps getting more different every time, something's wrong, because it's not converging. Right, so this is the displayed number after you press equal sign so many times. So in conclusion, in 2 decimal places, the answer is 0.62. Alright, I'll see you again next time.